Now let's answer example number 2. Lovely, Rika, Cassie, Jaira, Trisha, and Akira will be sitting at a round table. How many ways can they arrange themselves if letter A, no restriction, they can sit anywhere. So, for letter A, take note of the word no restriction. So, kung no restriction yan, ang hahanapin mo lang is is the value of your N. What is N? Okay, so based on the problem, saan makikita yon? Ito, Lovely, Rika, Cassie, Jaira, Trisha, and Akira. Ilan lahat sila? 1, 2, 3, 4, 5, and 6. So, 6 yung pinag-uusapan natin sa problem natin. Okay? So, therefore, N is equal to 6. Now, next, based on the problem, they will be sitting at a round table. Take note of the word round. Okay? So, if we are dealing with problems about permutations, nabasa mo yung round, ibig sabihin, this problem involves circular permutation. Okay? Kung circular permutation siya, meron tayong susundan na formula to solve circular permutation. And what is that? So, the circular permutation is equal to n minus 1 quantity factorial, in which substitute mo lang yung value ng n is equal to 6. So, magiging 6 minus 1 quantity factorial. And 6 minus 1 is 5. So, 6 minus 1 quantity factorial is equal to 5 factorial. And 5 factorial is evaluated as 5 times 4 times 3 times 2 times 1. And that is equal to 120. So, Lovely, Rika, Cassie, Jaira, Trisha, and Akira has 120 ways in sitting, in arranging themselves in a round table. Okay? Next, letter B. Lovely and Jaira insist on sitting beside each other. Ayan na naman tayo yung gusto ng dalawang mag-friends na yon na magkatabi sila. Okay? Again, round table tayo. So, ang formula pa rin na gagamitin natin ay pang circular permutation. Pero since arrangement ito, para mas madali, mahirap kasing mag-ayos kapag pa-circular. Tama? So, ang representation lang na lang na gawin natin ay pa-row. Okay? So, ilan yon? May 6 na uupo sa round table. Tama? So, 6. 1, 2, 3, 4, 5, 6. Okay? Si Lovely, tsaka si Jaira daw, gusto nila magkatabi silang upo. Or should I say, magkatabi sila sa, tama, upo sila na magkatabi. Okay? Next, if that's the case, etong position nila magiging isa na lang. Katulad ng example natin sa una. And then, diretso ka lang sa counting dun sa natitirang upuan. Okay? Next, so from n is equal to 6, since etong dalawa gusto magkatabi, si Ella at si Lovely at si Jaira gusto magkatabi, automatically itong arrangement nila 2 factorial na. Okay? So kung bibilangin mo yung seats natin, ilan na lang? 1, 2, 3, 4, 5. So from n is equal to 6, ang gagamitin mo dito, n is equal to 5 na lang. Okay? Ito na yung n mo, hindi 6. This is not your n value. Okay? But provided yung arrangement ni Lovely at ni Jaira ay 2 factorial. Saan nakuha yung 2 factorial? Say, sa unang upuan, si Lovely muna, tapos sa pangalawang upuan, si Jaira. Magkatabi pa rin sila. Meron din, si Jaira muna, tapos si Lovely muna. Okay? Meron pa bang way or arrangement na kung saan dapat sila ay magkatabi? Wala na, ganyan lang ang arrangement nila. So, ilang arrangement yon? 2. So, factorial representation nun, 2 factorial. So, dun nakuha yon. Okay? Okay, next. If that's the case, let's continue. The permutation in which Lovely and Jaira insist on sitting beside each other will be n minus 1 quantity factorial times 2 factorial. Saan galing itong n minus 1 factorial natin? Yung n minus 1 factorial natin ay galing sa circular permutation. Kasi nga, sa round table sila uupo. Okay? Next, ang N natin dito ay hindi 6, kundi 5. Kasi nga, si Lovely at saka si Jaira ay gusto magkatabi sila ng pagkakaupo. So, yung N natin dito ay 5. Okay? Now, next, saan galing yung 2 factorial? Ang 2 factorial galing dun sa arrangement na kung saan magkatabi si Lovely at saka si Jaira. Okay? Now, next, by substitution, we have N now will become 5. And 5 minus 1, that is 4. 5 minus 1, quantity factorial, that is 4 factorial. So, 4 factorial times 2 factorial. 4 factorial is 4 times 3 times 2 times 1. And 2 factorial is 2 times 1. 4 times 3 times 2 times 1, that is 24. Times 2, that is 48. Okay? So, Lovely and Jaira has 48 ways on how to sit beside each other. Okay? Next. Letter C. Rika and Akira refuse to sit beside each other. So, hindi sila magkatabi nung araw ng may event siguro. Kaya si Rika at si Akira ayaw nilang magkatabi. Okay? Pag may case ka na ayaw nila magkatabi, refuse to sit beside. Okay? Kung ayaw nila magkatabi, ganito ang gagawin mo. The permutation of Rika and Akira not together will be the difference of the permutation with no restriction and the permutation of two must sit together. Saan mo nakukuha itong two must sit together? Okay? Kung ilan ang ayaw, say isa, dalawa. Dalawa ang ayaw magtabi. So, ibig sabihin, yung dito, dalawa ang gusto magkatabi. Okay? Dun sa formula mo. So, what if ito, tatlo ang ayaw magkatabi. So, tatlo ang ayaw na magkatabi. So, ito, yung pag sinolve mo na siya sa solution natin, tatlo dapat ang gusto magkatabi. Okay? So, kung halimbawa, apat naman ang ayaw magkatabi, automatic yung gusto magkatabi ay apat din. Okay? To balance the whole equation. Okay? Now, next, no restriction tayo. Sa no restriction natin, ang n natin ay 6 sila. Tama? Next, ito namang sa isa, two must sit together. Ang two must sit, ito, sandali. N natin is 6 dito, di ba? N is equal to 6. So, that is n minus 1 quantity factorial. Tama? Now, next, two must sit together. Since together yon, ang count na lang ng isa ang count na lang ng position ng dalawang magkatabi ay isa. So, ang n na lang dito ay 5. Tama? So, ito ang magiging n minus 1 quantity factorial times arrangement. Okay? Kung dalawa yung gusto magkatabi, ilang arrangement nilang dalawa. So, this one will become 5 minus 1 quantity factorial times yung arrangement ng dalawa, that is 2 factorial. Okay? Dito naman, 6 minus 1 quantity factorial, that is equal to 5 factorial. Okay? So, we will be arriving with the permutation of no restrictions, that is 6 minus 1 quantity factorial. Tapos, yung 2 must sit together naman is 4 factorial times 2 factorial. So, 6 minus 1 quantity factorial is 5 factorial. Okay? Now, 5 factorial is 5 times 4 times 3 times 2 times 1, and that is equal to 120. And 4 factorial, 4 times 3 times 2 times 1, that is 24, times 2, that is 48. Okay? So, that is 120 minus 48. And 120 minus 48, that is equal to 72. So, Rika and Akira has 72 ways in which they will, or ways or chances na they will not be sitting beside each other. Okay? And with that, you will be answering activity number 7, yung natitirang item natin, decisions from permutation, item number 4, page 297. So, ito siya. Sabi niya, there are 12 people in a dinner gathering. In how many ways can the host, one of the 12, arrange his guests around a dining table? So, around a dining table. Word around, that means circular permutation. So, kung circular permutation nito, itong example, itong number 4 natin, katulad siya ng example number 2. Okay? Next, let's begin. Letter A, they can sit on any of the chairs. So, example number 2, this is example number 2. Number 2, letter A. Next, 3 people insist on sitting beside each other. Ito, katulad siya ng example number 2, letter B. Yung sa letter B natin, 2 people. Ito naman, 3 people. Okay? Next, letter C, 2 people refuse to sit beside each other. So, example natin, katulad siya ng number 2. Example number 2, letter C. Okay? That's it. You have to show your complete solutions. Okay, that's it for activity number 7, solving problems involving permutation.